Hey everybody, it's Norm from Tested, and today we're going to have a first look and review of Bambu Lab's H2C high-end desktop FDM multi-material, multi-color 3D printer. So this thing it's kind of crazy. It's almost like a piece of science fiction technology. This year's been a big year for Bambu Lab. They announced and launched the H line of printers, which is more so than the X or the P or the A line, really been a platform that they've made to experiment and release different versions that have really different, for us, different purposes and fulfill different needs while maintaining these fundamentals that they've developed in this generation of printers, from the size and the volume, the chassis, the linear rails, the new extruder systems, the sensors, the heated bed and volume, all the good stuff, the things that we've loved about the H2D and the H2S, they've now added a little bit of a twist with this Vortek hotend exchange system, this hotend rack here on the right side of the printer. They teased this back in late September with the launch of the H2S. Now, let's be clear, this is a hotend swapping system. It's not a full toolhead swapping system, and there's an important difference. So printers like the Prusa XL, that's a 5 toolhead swapping system, and each of those toolheads is an end-to-end complete system, from the filament spool to the PTFE tube to the extruder, the heating element, the nozzle. You have 5 of those that get swapped along the XY carriage that allow for really fast and convenient and robust swapping of materials. So you can really do a lot of interesting mixing and matching of materials. What the H2C from Bambu does here is actually just on the last part of that whole sequence, swap out the hotend. And it's a new hotend here with the Vortek system. And so actually inherited from the H2D is a dual extrusion system. 2 extruders up to now 1 on the left side, 6 on the right side, up to 7 different hotends. 7 different colors you can print, different materials, although up to technically 24 if you feed in multiple AMSs, but then you lose some of the benefits of that fast swapping and minimizing of the waste. So interestingly, that because it's using that same extruder system and the Vortek is only on the right side, on the left side, the left nozzle is the older, same hotend. If you've already invested in the 0.2, 0.4, 0.6, 0.8, or the high flow hotends of the H series or A series, that's still being used here. On the right side is the new Vortek hotend. And so I guess we should talk about the anatomy of how this exchange works, how this futuristic looking rack here works, because you have 6 slots across 2 rows. So a top row and a bottom row. And in the bottom, you see a stepper motor here that drives a belt that allows you to quickly adjust between the top and the bottom. And you can see here, there goes the top, and there goes the bottom. I'm manually doing it now, but you actually, in the software, in the system, you can say row A at the top or row B at the top. And the reason you would change this from top to bottom is because you actually can manually pull out the hotend. See that? That's just magnetically attached, and I just pulled that out. No clasp, no removing of a shroud or plastic shroud. That just gets pulled out, and you can pop that back in. Now, it has to be easy for me to manually swap these out because that's what the toolhead, the extruder, is actually going to be doing. At the top of these, if we look at the top of these hotends, what looks like a nut there, and that's where the filament would feed in, that piece is what the extruder actually grabs onto, locks onto. And if you look lower down on the hotend, on either side, there are magnets. On one side, there's a square magnet with 2 circles above it. Those 2 circles are actually just registration holes that allow it to align onto the slot on the rack. And then on the flip side, there's a large rectangular magnet that helps secure it to the tool head as it's being used and heated up and filament flowing through it. But the way it's being grabbed is that nut at the top. So as you can see in this B-roll footage of the rack being used and interchanged, it's so mesmerizing. The tool head secures and locks onto that top part of the shaft. The rack pulls down, and then that's how the hot end separates and gets locked onto the slot. That happens so quickly. It's really just remarkable and impressive. Now, the other interesting thing about this system is how the printer knows which hot end or what's going on with that hot end. Because as you saw me swap it in the old system, if you've swapped in, 0.2, 0.4, 0.6, your hot end, you go into the menu, you go into the printer and you say, I have put in this diameter hot end, this version, this stainless steel one, this hardened one, this high flow one, into that slot, into the tool head slot, so the slicer can know what you use. The system here has to be able to recognize by itself what hot end that is. And so if you look at the top, there's actually a PCB mounted to the top of this hot end. I see a couple microchips, and if you look at that corner, what looks in that trace, I think that's actually an antenna that allows for a high frequency wireless signal to transfer when there's power connected, because there's two contacts on one side. When there's power connected to this PCB, it allows a little bit of a transmission of a signal to let the printer know what hot end you've put in. And that's important, not just so it knows for the slicer to know what's going on, but also so it knows what temperature it's happening, because it's using a new type of heating system. It's an induction-based heating system. And so there are coils behind that tool head that then also heat up this insulation here. And you can see at the tip on the side here, two tiny wires, thermistors, that measure the temperature. So as the nozzle is heating up, it sends that information again back through that wireless connection to the printer so it knows when it's at temperature. All that has to happen wirelessly, so Bambu Lab developed it, so they say it's to improve the longevity and reliability of the system. And for me, so far, it's worked pretty flawlessly. It's been remarkable how fast this thing changes and swaps. So speed, of course, one of the priorities and advantages of having this type of swappable hot end. But waste, filament waste. So with the H2D, one of the things I realized was just by adding a second nozzle, just by having two nozzles, depending on the type of model you're printing, if you weren't doing per layer a ton of color changes, you could actually have very little filament waste. You can have what you think of on one side, your dedicated primary color, the base color of a model, and then per layer, if you're swapping between, adding eyes, black eyes to a character print, when it reaches that height, you would then have to flush and change out the filament, and then you would only flush when you reach the next layer. And so as long as per layer, you're not going crazy in terms of how many colors, two nozzles was pretty powerful. More complex models, you have many more color changes per layer. And here, now up to 7 different colors. The idea, when working optimally, is if you're printing up to a 7-color print, you're only going to have 7 pieces of poop. That's it. The savings, if you're printing a small, thin, narrow, tall character or model with a ton of different color changes per layer, you're still only going to be flushing that one time. It needs to flush, of course, to get rid of the color of that filament that's still in the pipeline of the extruder, even after it's cut off at the tip of the tube there. And there are ways in the software to mitigate flush, flushing into the supportive model, into the interior cavity of the model, but then you risk things like translucency and colors bleeding through and popping up behind a model, which has not really looked great in the past. But with up to now 7 different colors that you can swap with very minimal poop, again, depending on the type of model, how many color changes per layer, how tall the model is, that's potentially a lot of time savings. But what I also learned is not maybe a ton of material savings, because you still have to use a lot of materials in the prime tower. Priming is something that still has to happen, very different than flushing. And so if we walk through what happens when a tool head gets swapped. When one color wraps up and a second color, before a second color starts, there's a series of steps. And so let's go through the footage and see what happens. The first step is there's got to be a post-color priming step. So what happens is after one hot end's finished doing its pass, the hot end has to cool down. And as it's cooling down, it doesn't cool down immediately. Some of that filament in the hot end can drip. And in the H2D, you had this stopper that moved from left to right to block any filament from dripping. On the Vortek rack, these hot ends don't have a stopper in each of these spots. And so once a hot end gets into the spot, if it doesn't do what's called filament ramming, you're gonna get these unsightly drips. So it has to do that step. Okay, so it does that. Then the filament gets retracted out of the AMS or back into the AMS, into the spool. The hot end does its magical robotic swapping in the Vortek rack. And then you feed the filament back from the AMS into the hot end, into the extruder. It heats up, which we've timed, takes about 8 seconds as advertised. And then there has to be some additional priming as well. And this is where there's been a lot of kind of interesting debate and tuning that's happened in this early test and review period, because that priming takes some extra filament in the prime tower. And there are actually 2 settings in Bambu Studio. There's a standard purge and prime, and then there's also a high efficiency, faster prime setting. The amount of time saved between the standard and the purge saving mode ends up just being a couple seconds, but that does add up, as well as the amount of filament that's used in that prime tower. When printing a simple object, a single object, I found that as much material was being used in the prime tower as was being used in the actual print itself. And so, as the case with multicolor printing, it's always in your best interest to be printing multiple batches of objects. And they don't even need to be the exact same objects. I found a lot of luck kind of remixing using the same colors, but changing just the patterns of the objects. And you can still print dozen of them on that build plate all at once to make use and maximize the prime tower here that's being used. All in all, the total time it takes to go from one color to the other color ends up being about 40 seconds. I say about 40 seconds because the one thing the system doesn't take into account is actually the length of PTFE tube between the printer and your AMS. And this isn't a consideration I had to deal with before really diving into multicolor printing. And you think about it, the system has a sense of how long it takes to heat up, what it needs to do to swap and prime, but that one external factor, the length of tube and the time it takes to go from spool through the PTFE tube into the actual extruder itself, that is also time that can add up. And there's ways in which you can place the AMS and shorten that length, make sure there's no strain or awkward bends that the tube can, the filament can get stuck in the tube, and hard angles. There's an art to actually laying out your AMSs into the coupler to maximize that filament swapping time change. The system, I feel like, could do more optimizations and maybe do a calibration step to do some measurements for how long it takes to retract the filament and how long it takes to feed the filament. And right now there seems to be a little bit of that dead time between swapping the hot end, feeding the filament from an AMS that could, I feel like there's ways to optimize that or ways to calibrate that, just not in the slicer software just yet. And because of the space the Vortek printer takes up here on the right side, this has the smallest build volume of all the H line of printers, although it's actually very comparable to the H2D. So while it says 330 by 320 by 325 millimeters, if you're just using the right hot ends, the Vortek hot ends, you're only able to print on 300 by 320 by 325, which is the same volume as the H2D. The H2S, though, can print up to 340 by 320 by 340, which is why I can imagine they didn't put a Vortek on both sides of these machines, although, ooh, that would be such an interesting design. Much reduced x-axis, but that's like 12 different materials and colors. But I've really taken to printing multicolor prints. And it's gotten to a point where, I've been doing 3D printing for my kids, and they're just kind of sick of single color prints. It's not even interesting anymore. Even the ones that we end up painting, they love multicolor prints. And even though we could do plenty of multicolor prints with the H2D before, with the H2C, having individual layers have lots of colors, it's just that much more interesting and robust. And really, that's, I feel like, who this printer is for people who are printing lots of objects, lots of multicolor objects, potentially to sell. I know there are a lot of places where you can buy the rights and get the proper license to resell a physical print online on places like Etsy or at a farmer's market. And if you have those rights and you use a printer for manufacturing to sell, you can do a whole lot more. The time savings, the material savings, and just being able to go with more colors, that time is money, could be money to you. In terms of print quality, it was pretty great for the standard settings, mostly printed in 0.4. Didn't have any clogs with 0.2. The nozzles themselves are more expensive. The hot ends are more expensive. So the standard hot end is $21, and the new hot end, the Vortek hot ends, are $40. So twice as much. Haven't had any break, and if they do get clogged, Bambu says you can do a cold pull as you would do with the other hot ends to declog them. It is interesting that the system doesn't ship with 7.4 nozzles. They actually have this weird mix of 1.4 of the old model that goes on the left side and on the right side, 4.4 millimeter nozzles, a 0.2 and a 0.6. Feel like maybe they should have just included all 0.4, so you can go for 7 colors and not to spend $80 on 2 more 0.4 millimeter nozzles. And there are a bunch of different SKUs for this as well. All of them have to come with the AMS2. I think the pricing is pretty fair if you're talking about how this sits along the whole line of Bambu printers. It's, remember, $1,250 for the H2S, no AMS, $1,500 for the H2S with the AMS2. The H2D is now on sale right now. It's $2,000 for that model with the AMS2, and then the H2C launches at $2,400, $400 more for the Vortek system, and that does include the AMS2. There is a laser version of this as well, both 10 watt and 40 watt. I believe the 10 watts up to $3,000. But my take on that, with all the electronics and increased complexity of this mechanical complexity of the Vortek system, I am a little bit hesitant to use this as also a laser cutter with potentially the fumes and the mucking up of all the smoke. The H2D and H2S eventually, early next year, will be upgradable with the Vortek system. Although Bambu has said that's going to be a little more involved process to do that upgrade, but we'll hopefully be able to test that out. And if you're looking at these line of printers, I mean, we're so used to the H line of printers, like this build volume really has been pretty wonderful to work with this whole year. My favorite in this lineup of printers is still the H2S, the single nozzle printer. That workhorse for our studio. We use it to print, have one dedicated for PETG, and it just burns through that. I have one at home that I use to print a child-size helmet, just like I said in my review, perfect for child-size helmets for Halloween this year. Really been loving printing on the H2S and having a lot of fun with H2C, although it is, again, it's a pretty expensive investment if you're just using it as a hobby printer and not making money with your prints. I'd love to know what you think about multi-material and multi-color printing, and what you think about the difference between a tool head changer and a hot end changer, and whether being able to print in up to 7 colors is interesting to you. Share with me the models you'd like to see tested on this machine. We'll print them and we'll come back and check back in with H2C in a couple months when we're able to do that upgrade from our other H series printers. And we'll share some of the time lapses of those prints on our channel, either here or on the Tested Team channel. But thank you so much for watching. It's been such an interesting year for 3D printing, for FDM 3D printing. So thanks so much for watching. We'll have more to come. The year's not over quite yet, but thanks, and I will see you next time. Bye.
One of the most difficult things I have ever done in my life was write this book, which I did in 2018, released it in 2019. And I've been noticing as I do the cons and sign autographs, that a lot of people are bringing purchased copies of my book for me to sign. So we thought, let's make them available at adamsavage.com. This one was ordered by Zachary for his friend David for his birthday. Happy birthday. Oh, whoop. There we go. Everyone's different. AdamSavage.com.